says that the lead term is, this is a standard module. It's the full principal series with lots and lots of pieces. And then you have to subtract off some other standard modules. And then it's like inclusion, exclusion. Add some other things in. And the last step, subtract off the 4 discrete series. And when you're done with that, all what you're left with is a multiple of the trivial representation. All right. So let's do a couple of other examples. Let's take the split group of F4. If you print out the block of the trivial representation, I forget how big it is, it's in the hundreds. I just extracted a bit of it. There are these 4 representations labeled 316, 317. These all have the same X. And having the same X, what does that mean? Well, it means you fixed your real Cartan, and they all have the same nu. They just have different lambdas. So what you're getting here is you have some fixed h of r, and you have chi 1, or whatever the numbers are, chi 316, 317, 318, and 319. And these all have the same differential. And they only differ by, some signs on some R cross terms. And that's the hard part, getting those signs right. And, well, if you look at these 4, this is lambda plus rho. This is slightly different notation. So this means that lambda, to get lambda, you add rho to this. So for this representation, lambda is rho, and for these other ones, it's not. And oh, right. These nus, again, they're not rho, but that's okay. They're equivalent. They're equivalent to rho. And so, so you ask yourself, these 4 representations with these 4 characters, which is the one that occurs in the character formula for the trivial representation? It's the one where lambda is equal to rho. And that's what you get here. When you print out the character formula for the trivial representation, you get this x is equal to 226. There's exactly one term with x is equal to 226, and it has lambda is equal to rho. And so that's this guy, number 316. And so this sum is over all of the KGB elements, rho, rho. And that's, I like this point of view because, one of the really hard things is pinning down these bijections and how do you figure out the character of the component group and everything. And this is what pins it down for you. And then if you need to know, so for example, if I told you that that this character, that this parameter is the one where the character of the Cartan is a restriction of an algebraic character, you can figure out the rest of these by cross actions. You can move around and figure them out. So once you've figured out these sort of base points, you can figure out everything. Yeah, I mean, it's just, this is just lambda minus rho. So down here, lambda is rho, and so lambda sub rho, which is lambda minus rho, is 0.
So the numbers are what? Coefficients of the fundamental?
Well, they're...
That's correct.
In this case, yes. Yeah, so to say that lambda... Well, look. Well, so look at lambda. Here, I'm telling you that this is rho. That's obviously fundamental weight coordinates. But like when I did SP4, when I did SP4, rho was equal to 2, 1. So that's not fundamental weight coordinates. It's some other coordinates. And it's whatever coordinates Atlas chose to use for this particular group. since F4 is simply connected, it's using fundamental weight coordinates. Okay?
So how do I read from this what the M character is?
So for this guy, it's the holomorphic. It's the character.
These are principal series, am I wrong?
No, I don't think so.
Okay, then,
No, they're not.
okay.
So they're on some intermediate Cartan. So I mean, if well, I don't want to try and print it out. We're about out of time, but I'll just say, if you were on the split Cartan, or if you had a principal series, and you have some lambda, then 1, 1, 1, 1 gives you the character chi of t is rho of t, literally rho. And so the signs, I guess, are all minus. And then, so that says that chi of m alpha is equal to -1 for all simple alpha. Right? Yeah.
You said something about fixing a base point and then being able to.
Right.
So what's the base point?
So these 4 parameters, they all have the same x, and they just have different lambdas. And by looking at the, if I told you this parameter with this lambda, and then I told you how you looked at that table of Cayley transforms and cross actions, you could compute these other 3 lambdas from this one. I mean, David's good. The computer can, yeah. Oh yeah, so let me just wrap up. There are 2 commands in Atlas: print composition series of P and print character formula of P. And this is an example where you have to be careful or be aware of what P stands for. So when I say print composition series of trivial of G, well, the composition series is only a question you would ask about a standard module. So this must mean, please tell me the composition series of the standard module with this parameter, and the answer is to be interpreted as a sum of irreducibles. Conversely, if you ask for print character formula, it must mean this is the trivial representation, and this is the formal, this is how you write it as a linear combination of standard modules. And unfortunately, there are times where it, it gets confusing about what P stands for. And so let me just conclude. This is my last slide. At some point, I started implementing something I call modules notation, which is supposed to help with this. And I haven't implemented it thoroughly in the software, and I'm not sure at this point whether I will or not, but what I put in a method so that you could have standard and irreducible modules and have them be distinguished. I stands for a standard module and J stands for an irreducible. And so when you ask for the composition series of a standard module, it tells you that the things that you're getting are irreducibles. And if you ask for the character formula of an irreducible, it tells you that the things that you're getting are standards. And if you ask for the composition series of J, rather than printing out something, it would give you an error, say, that's not what you mean, instead of giving the wrong answer, or not what you were expecting. So I'm not sure whether I'm going to try and use this notation more systematically or not. Thank you.